And now we're going to move on to the Read JSON from Files section. In this section, the first thing that you're going to want to do is install the library or the package called OurJason. To do that, you'll just run this line that says install.packages, and as the argument is just a single string that has the name of the package, in this case OurJason. I'm not going to run this because I already have this installed, but by default for R and RStudio you won't have that particular package, so you will want to run this. And once you have, then you'll load the library by calling this line right here. So it's just library, and as the argument you're going to type OurJason as a variable name. Then what we're going to do is move on to loading up this data. So included with this particular tutorial, you have issdatasample.json. So this is just an extremely small, simple JSON file. We're going to load this up using the method from JSON, where JSON is all caps, and do specify file equals. If you leave off this part right here and just assume it's the first argument, well, you'd be wrong, and it would be expecting a JSON string. So if you didn't want to load from file, but you had some JSON as a string in memory, or some string that you want to type or paste, then you would use that as the first argument. We can see that in the lower right here, where it would be JSON string, whereas otherwise we actually want to pass in the file. So we'll run that, and we're going to take a look at this. So we have our output right here, and in R, if you're used to Python where you'd see something that looks a lot like a dictionary, which would look like the JSON itself, in R you're going to see a list that actually has names or attribute names for these different elements within the JSON itself. And for each of these having this money sign preceded by them, that's what you're going to use to access that particular attribute or that element in the JSON data, and we'll see that in just a second. So let's go ahead and take a look at the class for our ISS data, and we can see that this is a list. This is the generic way for R to handle things that are similar to dictionaries or just lists in general. Okay, so the first thing that we're going to do is see how we can access some of this data. In this case, we're going to get the ISS position. So we'll have ISS data, $, and ISS position. So we'll do that, and we can see this printout, which is also a list. So this tells us that this was a nested component of this JSON data. And we'll have the latitude and longitude. And we could access each of these if we wanted to by continuing on. So let's actually copy this right here, paste it down there, and let's say we only want the latitude. Then we use $latitude, and that's what we'll get. Okay, another thing we're going to take a look at real quick is this piece added to this, which is an array in the JSON file. So this is just going to output a single vector. In this case, it's a numeric vector. We can see that by running class over that, and we can see it's numeric. So that tells us it is just a numeric vector. We can also access multiple elements inside of this particular data, our JSON data, which is now a list or nested list. So we'll use ISS data at the beginning, and then we're going to put square brackets, and inside the square brackets we'll add a vector that contains any of the particular element names that we're interested in retrieving. So we'll hit Command Enter on that, and it's going to give us our timestamp and message, which we can see here. And so we have a particular timestamp. It looks like that one is in POSIX, so it's just seconds since 1970. And then we have our message, which is success. Yay! Okay. So that was fun. All right, let's go ahead and move on to read binary data from file. The file that we're going to be using for this particular piece here is bond.wave, or at least one of them. So we have bond.wave, and we're going to be using the readBin method. Similar to what we've already seen with readCar and readLines, we can pass in just a path to a file. And another thing that we can actually do, which we have not yet discussed, is to pass a connection object as the first argument. So it'll either take a connection object or a string for a path. Connection object is going to come in down here. We'll see those in a moment, but let's just get started with this. Whenever we use readBin, we need to pass a value for what. So the argument what is basically telling it what kind of binary are we going to be reading. So if we're not sure and we just need to see the bytes data, we're going to say what equals raw. If we happen to know that all of the data is numeric, then we would pass that accordingly. So for example, it might be int or integer if we know they're all integers. And also what we need to do is pass in this n value right here. And what this is going to be doing is telling it the number of records, or in this case bytes, to read. And if we want, we can use just some very large value. In some cases, like if we were to pass character to this, there's, I believe it is a 10,000 limit for this right here. And that's what we happen to have in this case, is just 10,000. So 1e4, just scientific notation, we have 1 times 10 to the 4. And since we're reading in bytes, that's going to give us 10 kilobytes. Okay, so we're going to load this file, which is bond, and let's take a look at just the first 10 bytes in this. So we can see here we get a vector, which shows us our bytes, and these are just the first 10 bytes of what we've read in. You may not have seen this before, and you don't need to understand what these are for this tutorial. Just know that those are essentially just the representation of our bytes in this case. And the default for here is going to be showing just 2 bytes at a time. Okay, another thing we can do, while the purpose of this tutorial is not specifically to show how to write different file types, we are going to be looking at, real quick, just this write bin method. And we're going to be writing what we've already read in, and we're going to write it out to bond2.wave, just so you can see what it looks like. So the full file is actually larger than 10 kilobytes, so we've only read in a portion of it. So you're going to write out what we've read in, and feel free to play that and compare it to the original, and you can see that we only have part of the audio there. So we'll just run that, and it would write it out to the same location as wherever your current working directory is. And by the way, that audio is going to play back just the first portion, which is, "Who are you?" All right, let's see, we can also read in images. So we've included the lightbulb.jpg or JPG, and we're also going to pass what equal raw. And in this case, we're going to read in roughly 60 kilobytes. So we're going to give it a limit of 60 kilobytes. The image should be about 58 kilobytes. So we'll read that in. And if you wanted to, you could also read that, write that back out and see what you get. You could always try playing with some of the bytes, altering the values, and see if that breaks things or if you just get a funky looking image. So also, just to see real quick, we can get just the first 10 bytes. And what does it say? Unexpected. Oh, okay, so those are Python habits there. In R, you need to specify the first index always. It doesn't just assume it is the first. So there we go. First 10 bytes of this one differs from the other, as we can see. Okay, so now let's read in, I was about to read that line verbatim. So we're going to read in a binary file that contains integers. We have this file that ends in .dat, and we're going to use this connection. So essentially what this is doing is it's just opening a connection to that file, similar to using open in Python. So if you're used to Python and you have the open function, which you may either just open and then close it later or use with open, this is very similar to that. So this creates that connection for us. And we're going to use RB, this says read for the R, and then binary, which is the B. So we'll read that file. We aren't actually reading it in, it just opens the connection to it. We're going to use this read bin and pass that connection object. And what, this is where we're going to tell it it is reading integers. And we're just going to read the first integer. By the way, when we call on a connection object, when we're passing in just n equal 1, what we're doing is we're just going to read in the first piece of this, and then when we call it again, it's going to be keeping track. So it'll know that we already read in the first record, and now it's going to read in the next 4 records. So we're going to call read bin, and we can see that the first value is 0. And then we're going to print the next 4. So we have 1, 1, 2, and 3. And let's yet again get the next 4, and we have 5, 8, 13, and 21. If you're familiar with it, you'll see that these values are actually the Fibonacci sequence, or Fibonacci series. Okay, so for the last part of this, and we're pretty much at time now, but let's finish this up by giving you a slightly more complex example. So we have a very small data set here, and we're going to see how we could read that in. So this is a small table. If you know the structure of your binary data, then you can reconstruct it. If you don't know the structure and you don't know what you're dealing with, it would be very difficult to do so. For example, some programs, some applications will write to binary files, but if you have no idea how they wrote to it and specifically what is inside of it, what the structure is like, you'd have a difficult time reconstructing it, but it is possible. In this case, we know that it's going to be an array with column names, or a table with column names. So the first thing that we'll do is let's just call the read bin and say what equal character. So that's just going to print everything out down here. And we can see that we've got certain funky values. The first three are readable. We have call 1, call 2, call 3. And then we have these values that don't necessarily make a lot of sense. We do have what look like some escape characters, but by reading in, for example, integers or numeric values as character, they tend to come out looking a little funny. But this gives us some insight. It looks like we have 3 columns here. So let's change this just a bit, and we're going to use this connection object again. By the way, we actually never closed the initial connection that we had. So we're going to do close and F before we move on to the next one. And let's open another. So we have small data.dat and read binary. And once we open that connection, then the first thing we can do, as you've already seen, we can read in a certain number of records using read bin, and then it'll move on to whatever remains. So we're going to create our column vector here, or just essentially a list of our column names. So we're going to call read bin what equal character, and we're only going to take the first 3 records since we saw there were 3 columns. And it looked like the rest of our data was all integers, so we're going to read in the rest of that. So we're just going to set a larger value for n here than we know we have. So we know there are only a few records, so we'll set n to equal to 100, and we'll call that our data. So we'll do that, and let's check the values. So our columns, here's our little vector right here of our column names. And then we're going to check the data and the length of our data, because we don't know yet exactly the shape of whatever array this is, or whatever table. And so here's our output, 142, 536. Those are all the different values we have. And it looks like the total length is 6, which, yes, that's easy to count by hand, but for a larger amount of data, we wouldn't want to count it manually, so we just get the length. Okay, so we have 6 values, and we have 3 columns, which means we have 2 rows. So 2 rows of 3 columns. That'll make it easy for us to reconstruct this. So we'll just say d equals, and we'll create a matrix using data, and row equal 2. And let's actually see what that looks like. So right now, we don't have column names. We just have 1, 2, and 3, but here are values 1, 2, 3, 4, 5, 6. Okay, so in order to set the column names, since we already have that, we're just going to wrap this method callNames around d and say that equals calls, which is our vector of column names. And let's print out d again, and here it is. So our data is now reconstructed from this binary file.